Welcome. In this presentation, we will learn about test statistics and their role in hypothesis testing. In this video, we will learn what a test statistic is and why it is important in hypothesis testing. We will see the formula for a test statistic and learn the meaning of theta hat, theta naught, and standard error. Next, we will work through a simple numerical example and calculate a test statistic step by step. Finally, we will learn how to use the test statistic to make a decision about the null hypothesis, H naught. What exactly is a test statistic? Think of it as a ruler that measures how far our sample result is from what we would expect to see under the null hypothesis. The formula looks like this. In the numerator, we take our sample estimate, theta hat, and subtract the value specified by the null hypothesis, theta naught. Theta hat represents the estimate calculated from the sample. Theta naught represents the value assumed under the null hypothesis. The standard error measures how much the estimate is expected to vary from one sample to another due to random sampling. We then divide the difference between theta hat and theta naught by the standard error. In the end, this single number tells us how unusual our sample result would be if the null hypothesis were true. Let's work through a simple example. Suppose our null hypothesis states that the population mean mu is equal to 100. In this example, mu is the parameter of interest, and the value specified by the null hypothesis is represented by theta naught. Therefore, theta naught equals 100. From our sample data, we calculate a sample mean of 105. This sample estimate is represented by theta hat. Therefore, theta hat equals 105. Next, suppose the standard error is 2. Substituting these values into the formula, we take 105 minus 100 and divide the difference by 2. This simplifies to 5 divided by 2, which equals 2.5. Therefore, the value of the test statistic is 2.5. Before making a decision, we need to determine the rejection region. In this example, the alternative hypothesis states that the population mean is not equal to 100. Because we are interested in detecting differences in either direction, we use a two-tailed test. For a two-tailed test at the 5% significance level, the critical values are negative 1.96 and positive 1.96. The shaded regions represent the rejection regions. Our test statistic is 2.5. Since 2.5 is greater than 1.96, it falls in the rejection region. Therefore, we reject the null hypothesis. To summarize, a test statistic measures how far a sample result is from what the null hypothesis predicts. Larger absolute values provide stronger evidence against the null hypothesis. Smaller values indicate that the sample result is closer to what the null hypothesis predicts. By comparing the test statistic to a critical value or rejection region, we can decide whether to reject the null hypothesis or fail to reject it. Thank you.